Spiels with 3D printing news on Unpeeled, brought to you by 3dprint.com. So first, we've got these lovely lamps. They're from Ohio with 2H, or Ohio, and said a different way, made by Anna Marienko. And they are lamps, and you can order them from the website. They're 3D printed at the London studio of this design brand itself. They cost $200, and they're made with sustainable materials. They're meant to look like these oversized kind of knitted stitches, these things that she did before. But the thing I like about this, the reason why I'm talking to you about this today is that these are fun, right? They might not be your taste, or they might be super your taste, but this is kind of like a Memphis, kind of bubblegum Memphis kind of design aesthetic, and it's just fun. And it just reminded me that in 3D printing, we often take ourselves so very seriously when we make things. It's always like fractals or Voronoi, are very white and very kind of subdued, kind of artsy, high-end, high concept type of pieces. And this is just something that's super fun. And I think, I think that we should have more fun products like this. And what I also really like, they designed it, they print these things at their own studio, and they sell them direct as well. You go to their website, give them $200, and you get a lamp. So I like that directness and that clarity. And I think more people should be doing something exactly like this. So I think, this is a wonderful example. Really inspirational. I think, I would love for us to have more fun things. This is also kind of cozy. In Holland, we have this word called gezellig, which means like kind of like cozy and comfortable, hang out with friends, kind of, you don't have to pretend to be someone else kind of thing, like a really relaxed kind of environment. And these are kind of like cozy lamps, but in their own very way, and not this kind of mid-century, once more with feeling kind of design aesthetic, or this very modern look. It has something kind of like a new classic about it. I really like this. So I thought this was a fun thing to mention to you guys. The next thing is a wearable. So this is a wearable health monitor developed by Washington State University. It got published, the paper got published in ACS Sensors, and the paper is called a 3D printed flexible microfluidic health monitor in situ sweat analysis and biomarker detection. It's by Chu Chen, Yonghao Fu, Sonia Sparks, Zhaoan Luyu, Aryat Pradhan, and a bunch of other people actually. And it combines two areas where 3D printing is thought to be very strong. One is microfluidics, and the other one is wearables. Wearables has been the kind of the once and future king of 3D printing for many years. People have been talking about conformal electronics, or conformal batteries, or conformal things that are meant so that, it fits around your arm, or fits in a tight space a little bit better, with a lot more components in watches and other small medical wearables. The idea is to print things so they fit into these devices, or they combine fewer parts, or they're more kind of efficient mass-wise. Has always been kind of like a real big opportunity for 3D printing. And then also in the skin contact and kind of some kind of the membranes and the kind of sensors you want there, it's also thought to be really advantageous to do this. At the same time, microfluidics is something that should have been huge, or much huger than it is already. Microfluidics is the ability to precisely, at a very small scale, mix or drop one material into another material, mix four materials, or get a certain chemical reaction going, build a little mini chemical factory. And the idea is, of course, if you make that little chemical factory, you can have a really simple blood test, or you could have a really simple glue being manufactured, or a really simple kind of some kind of little mini kind of a chemical reaction producing a whatever, a solvent, a glue, or whatever, any kind of thing. And microfluidics have also, and wearables as well, basically have been a lot talked about, and have been growing, I think, a little bit shorter than people thought. Now, this is the intersection of those two things. So very promising, and also kind of buyer beware kind of thing. What this does, though, is really, really great. It's a 3D printed thing, and it measures through sweat your glucose and lactic acid, uric acid, your and that could be used by, for example, sports medicine people, dietitians, people studying diabetes, all sorts of other kind of diseases and things like this. Endocrinologists could use this. And rather than taking a lot of blood and getting the results back a couple of days later, you could just, in a very simple way, take this at home, get it sent home, or have it sent to you, or just put it on while you're at the clinic, and then you could quite quickly get a result from this. And of course, less invasive, less manpower, less painful way than having to get a shot. This is a really great thing. Now, of course, we all remember people that were promising, breakthroughs in medical testing that didn't make it. But this seems to have a lot more, be a lot more simple and a lot more faster way to perhaps in the future detect kidney disease or some heart disease or diabetes, like say, for example, in someone. And basically, it's a single production step, so that's really nice. And that means with 3D printing, you could scale this production technology to make a lot of devices, and you can perhaps do this inexpensively. So this could really very well have legs in the future. I would expect a lot more wearables with 3D printing, first off, and I would also expect an awful lot more microfluidic devices, because these things, because they have really discrete little tiny little channels and chambers and little mixers and valves and all sorts of things. They're very, very difficult to make. And often they take like 2 or 3 steps or some manual steps or lots of different processes to make these microfluidic devices. And the idea, of course, is that you can make millions of tests for something new or something like that. And that doesn't really kind of like really work well together. So 3D printing for us, of course, is to create these little valves or little chambers and things. It's relatively easy to do, and relatively automated way we could do this. So this again could be really big. Let's take it with a grain of salt and wait a little bit a while to see how far they get with this. But I think it's a great development. And the next thing is also great development. This is a footbridge in India. So first off, this is news because India is doing a lot of 3D printing construction things lately. They're building post offices and houses, all sorts of little buildings and stuff like this. And that's notable because India is a gigantic country with a lot of engineering talent that needs infrastructure. At the same time, the government has learned that, it can galvanize the world's and its own people's attention with kind of mega engineering projects. And rather than building a dam, they could do something a little bit more high tech. A great example of this is India's space program, which was universally admired essentially because, well, not only was it very effective, it was super cost effective as well. And it demonstrated that India could be a tech giant. And that is, of course, a great thing for India's politicians and its people, and it's a very popular thing to do. And lately, we've been seeing a lot of Indian politicians cozying up to construction 3D printing. There's some 3D printing being used in the Indian space program. And, you can see these guys show up for things. You can see these guys kind of promote it. So that it could be that they could get an extra push by politicians. At the same time, for construction 3D printing, there's a lot of need in the developing, semi-developed, and also developed world for things like footbridges. So I'm really excited. This is a 7.5 meter footbridge. So it doesn't sound like it's like, oh my God, it's a huge thing. But actually, this is actually a thing that tens of thousands of these things are probably needed in India. There are countries like the Netherlands and Belgium, that, let alone those small countries, will need thousands of these as well. So what's happened in a lot of areas, they don't have these bridges, right? In a lot of other areas, what they have is they built a lot of these footbridges and small bridges in the 50s, for example, or right after the Second World War, and these big reconstruction projects that were happening at the time. And these bridges are very old. They're maybe a little bit decrepit looking. They're old designs. Maybe the concrete's kind of falling apart. Maybe they would want to redesign them, make them different. So there's a real need. I mean, well, in Europe, you've got the problem that labor is scarce, labor is very expensive, materials are very scarce, and there's kind of contracting things per mile of roadway or per bridge because all the safety factors, all the things that are happening. It's actually quite expensive to do this now, much more so than in the past. In India, by the way, they have another problem. They have the labor, they've got the engineers willing to work, all the good stuff, but they have a lot of problems with the roads and getting things in the right place and that kind of thing in inaccessible areas, which of course you would need these things the most. So, this is another example of why this construction 3D printing is such huge potential. We're talking about tens of billions of dollars only available for footbridges, guys, footbridges, and so this is why I'm really excited that these guys are focusing on this. And this bridge was built at the Indian Institute of Technology, or IIT-Hyderabad. It was made by a local company called Simpliforge Creations. The professor in charge of it, KVL Subrahmanyam, I mispronounced that, my apologies. And he's from the Department of Civil Engineering. And again, this is a small thing, but just think of the volume. Just think of across the world, right? In lots of different countries, lots of different levels of GDP and investment, we need tens of thousands of these. So you can, in certain cases, if it's really remote, maybe even print this locally with robot arms. In other cases, maybe it's better to print it centrally and then to ship it to where it needs to go. But the idea of mass customizing these devices so that the bridge stands up to code, stands up to whatever you want to let go over it, to whatever span it needs and all this, and can then be printed without a lot of humans and without a lot of architects and things like that, could save people a ton of money and all sorts of different economies. So I think this is, of the 3D printing construction thing, all the excitement's about houses because that's relatable for people. but I'm much more excited by planters on the one hand, industrial buildings and industrial kind of things like cashments and water cashments, things like that, and also footbridges. And I know it's kind of a little bit boring. It seems a little bit boring, but believe me, there is a huge amount of volume behind this. So this could be a much, much bigger thing for the near term. Anyway, my name is Joris Peels, and this was 3D Printing News Unpeeled. I hope you found